Calculus is one of the interesting topics that we have in mathematics. It has two parts. The first part is what we call differentiation. We call it differentiation. Okay? And the second part is what we call integration. Integration. But in this video, we are going to dive into the world of differentiation part. What is differentiation? That's the first thing you have to have. The process involved in finding the change in one variable with respect to another variable is what we call differentiation. Okay? And the result of differentiating is what we call derivative. I repeat, the process which is involved in finding the change in one variable with respect to another variable, we call it what? Differentiation. While the result of differentiating is what we term derivative. So in this video, we are going to take this. The first point is to look at the ways of denoting derivatives. Ways of denoting what? Derivatives. Second one, we look at the general word now. General rule of differentiation. General rule of differentiation. Okay? The third one, we look at the word now, derivative. Derivative of the sum. Or we call it sum rule. Okay? Sum rule. Then after, we look at the word now, derivative. Derivative of a constant. Derivative of a constant. Then after this, we look at derivative of a product. And after this, we look at what we call composite function. Or we call it what now? Chain rule. Chain rule of what? Differentiation. Then after this, we look at what we call derivative. Derivative of the quotient. Derivative of the quotient that we call quotient rule. Okay? Quotient rule. Okay? Now, this one here can be called product rule. Okay? Now, after this derivative of the what now of the quotient, we'll look at what we call derivative. Derivative of the trigonometric function. Trigonometric function. Metric functions. Okay? Then after this, we'll look at derivative of the exponential function. So after this, all what we are doing here is under what now? Under differentiation. Please take note. Under differentiation. So the next thing, we look at what now? Derivative of the what? Derivative of the exponential function. Exponential function. Okay? Then after this, we look at what now? Derivative of the logarithm function. Derivative of the logarithm function. And after this, we shall look at what now? Derivative. We look at higher derivatives. Okay? Then after this, we now look at what we call application of differentiation. Okay? Under this application, we are going to consider what we call gradient of a curve. Gradient of a curve of a curve at a point. And after this one, under applications of differentiation, we shall consider what we call turning point. Bracket maximum and minimum point. Okay? Then after that, we'll talk about what the rate of change. Then the last one we'll talk about now, kinematics. Okay? So these are all the things that we are going to be discussing under what now? Differentiation. Are you with me in class? So please, before we go ahead with the what now, the video, I want you, if you are new come out to this channel, please subscribe to the channel by clicking the red subscribe button. Turn on the notification bell so that you get notified anytime we release what now videos like this. And if you are returning subscribers, we say thank you, God bless you. So let's go to the what now, to the video. So the first one is ways of denoting what now, derivative. That's the first one that we have on the marker board. Ways of denoting what now. How do we denote derivatives? How do we denote derivatives? Now pay close attention to this video, okay? Now, if y is a function, y is a function of x, it is written, how do you write that? It is written as y is a function of what now? Of x. Pay attention please. Y is a function of x means what now? Y depends on x. Y is what we call the dependent variable. Then x is what we call the independent what now? Variable. So what are the ways that we can use to denote what now? Derivative. We said derivative is the result of differentiation. Is that right? So how do you denote what now? Derivative. So we denote derivative like this, Denote ways of denoting derivative. Well, if you have y prime, it means what now? Find what now? Differentiation of what? Of this y. It means differentiate this y prime. Or they use f prime of x. F prime of x, or they use the y dx. Why do you use the y dx here? Because y is a function of what now? Of x. Pay attention. Y is the function of x. That's why we say what now? The y dx. Or we can call it f prime of x. We can say y prime. If k is now a function of t, if k is a function of t, in this case it means our k depends on t. So how do you now denote the derivative of this one? It will be that will say what now? K prime, okay, or we say f prime of what now? Of t, f prime of t, or we say what now? The k over the t, because k depends on t. That is why we are using what now? The k over what now? The t. Are you with me? Or we say f prime of t, or k what now? K prime. These are the ways that we use to denote what now? Derivative, which is the result that we want to obtain from what now? Differentiating a function. So let us go to the second one, which is the what? General rule of differentiation. So we are moving to the what now? Where the work starts. General rule. You can't escape questions like this under in what now? Whether in JAM or in YL. Okay, you cannot escape questions like this. Under calculus, you cannot. So the first one is what we call general rule of differentiation. So let us go for general rule of differentiation. We have this. These are the ways that we denote what now? Derivatives. So general rule of differentiation. General rule. So we have if y, let me divide the board. If y equals to ax raised to power n. This general rule, we can also call it power what now? Power rule. Now, our dy dx, meaning the derivative that I want to look for, which is what we are doing in this video, we are looking for derivative. Okay? I will use this power n to multiply this a to be a times what? N. I will now write this s bar. So I will write s bar. I will now subtract 1 from this word n. So I have what? N minus 1. This is what we call the general rule of differentiation. So what is the rule? I need power. I need what now? Coefficient. This y is the dependent variable. This x is the independent variable. Y depends on x. A is the coefficient. N is the power. What is the rule? I'll just multiply this power by what now? By the coefficient. Write the independent variable bar. Now subtract 1 from the what now? From the power. So okay. So let's take examples. Suppose I ask what now? Find the derivative. Find the derivatives of the following functions with respect to WRT means with respect to their variables. Okay, so that's the first one. Y equals to 4s cubed. Are you with me? Second one, k equals to 1 all over t squared. Third one, we have n equals to 5 n raised to power what? Raised to power 4. So let us stop here. Let us just solve this word now. These three words now, examples. What's the first one? We have to find the derivative. Look at this. Find the derivatives. Meaning we should find the result of differentiating this function. Are you with me? So what's the first one? Y equals to what now? 4s cubed. So we have y equals to 4s cubed. In this case, y is a function of what? Of x. It means y depends on x. Where is the constant? This is the coefficient. This is the coefficient, which is 4. Where is the power? 3 is the what now? The power. What's the first thing? We will multiply this power by the coefficient. So it means our dy dx, which is what we have to do, is equals to 4 times 3. Okay? And where is s bar? S is power what now? 3 minus what? Minus 1. Is that what? Look at the what now? Look at the formula. Look at the formula here. Look at the formula. So I'm following this formula. That's the general rule. So what is happening here? 4 times 3 becomes what now? 12. We have x raised to power 3 minus 1. That is 2. So the derivative of this function is 12s squared. Okay? Let me add one more. Let us say p equals to what now? Q. P equals to Q. Let's find the derivative of this. Is the what now? The fourth one. Look at this. This is the first one. Second one, let's go. We have our k is equals to 1 over what now? T squared. Class, now look at this. What can solve question under what now? Under derivative. We need the thing to be what now? Linear like this. It should be straight. It should not be something like this. Are you with me now? It should be straight. We want to use general formula. It should be straight. So this one from the law of indices. If you recall, under law of indices, one of the laws of indices, we have this. If I have a raised to power minus x, our result will be equal to 1 over a raised to power 1. Now, x is what we call the negative power law under indices. So, which implies this 1 over t squared, to be in index form, it will be t raised to power 1 now, minus what? Minus. Are you with me now? Because we have a raised to power minus x equals to 1 over what now? A raised to power x. So, this 1 over t squared will be equals to what now? T raised to power minus 2. So which implies this thing is same as saying k is equals to t raised to power what now? Minus 2. So fine. I now have the coefficient which is what now? 1. I have the power which is what now? Minus 2. K is a function of t. K is a function of t. So what are we looking for here? We are looking for the k dt. Because k is a function of t. So we have our k dt, the k all over the t will be equals to 1 is here. So we have 1 times minus 2. That then I'll write my t back. I have t raised to power minus 2 minus 1. So what do I have here? 1 times minus 2 is minus 2. We have t raised to power minus 2 minus 1 is what? Minus what? Minus 3. So this will now be minus 2 all over. So I'll come back. T raised to power 3. So that's the answer to this one. To this question. You can solve this one now. This should just be the n will give us what now? 5 times 4, 20. N, 4 minus 1, that what now? 3. So we have 20 n raised to power what now? 3 for the third one. So let me wipe this space off because I'm using that as a guide. Let me wipe this space off. So the third one, our n equals to 5 n raised to power 4. So here, n is a function of what? N. So we now have what now? The n. That will now give us what? 5 times 4. Then n is power 4 minus what? Minus 1. This will now be 20 n is power 3 from the general rule of what? Differentiation. What's the next one? The next one, which is D, we have P equals to what now? Q. In this case, our P is a function of Q. Okay? What is the coefficient? 1. What is the power? 1. So what I'm going to do, it means our the P, the Q here will be equals to the coefficient 1 times the power 1. then q raised to power what? 1 minus 1. Are you with me? So what do I have here? We have 1 times 1, that is 1, that is 1. So 1 times 1 will give us what now? 1 times q raised to power what now? 0. What is q raised to power 0? 1. Now 1 times 1, everything will give us 1. So it means if we have to find the derivative of what now? P equals to q. This our answer will be equals to 1. So we solve all this question from the general what now? General rule of differentiation. So what's the next one? Derivative of the sum, which we call the sum rule. Derivative of the sum, which we call the sum rule. Alright, so let's go. What is the sum rule? We have this. If y equals to, please look up sum rule. If y equals to u plus v plus w, okay, where u, v and w are functions of x, then what happen? Our divide dx, which is the derivative that we're looking for, divide dx will be equals to du over dx plus dv over dx plus dw over what now? What's the meaning? It means I'll just differentiate them one by one. That's all. This is what we call the sum rule. Example, y equals to 3x cubed plus 4x squared. Then find the y dx. We do it one by one. So it means our dy dx in class will be equals to 3 times 3, 9. Okay? I'm using the general rule. So, but it will be one by one. Are you getting me? 3 times 3, 9. Then I have my x. 3 minus 1, that is what now? That is 2 for this one. Okay? Then plus 2 times 4, 8. I'll write my x back. Then 2 minus 1 will give us what now? 1. So it will just be 9x squared plus 8x. Are you with me? So this is what we call the sum rule. This one, this function of x, this one, function of x, this one, function of x. What I need to do, we do it one by one. That's what we call the sum rule. Just do it one by one using the general rule. It means general rule will affect this. General rule also affect what now? Even if there are what now, like 10, which is one by one. Break it down one by one. This is what we call the sum. Let's take some question from what now? From JAM. Let's take some question from JAM. So this is the JAM question. If y equals to x squared minus 1 over x, find the y there. You have to be very careful. You have to be very careful. Very, very careful. So let me wipe this one off. I think I should be able to, let me break the board into 2. So we have this JAM question. It says if y equals x squared minus 1 over x, find the y dx. I'm going to give you all the laws, okay? We're not solving what now? General question from JAM. So A, we have the options. A, we have 2x plus 1 over x squared. B, we have 2x plus x squared. C, we have 2x minus 1 over x squared. Then D, we have 2x minus what now? Minus x squared. If I apply the general rule, so we have it like this. Our y is equals to x squared minus, this one will go up, so I think we'll be what now? Linear. So from here, that's what I'm doing from here. 1 over, if I have x power minus 1, it will give us what now? 1 over what now? 1 over x. Before I can apply the general rule, I must add power. So where is power? Minus 1. I will convert it to what now? To negative power form. What I just did here, similar to what I did here. So this will now be x power what now? Minus 1. Can I use what now? The sum rule to solve this question. So this our dy dx will be equals to, where is the power? 2. Where is the coefficient? 1. So 1 times 2, we have 2. Then x raised to power what now? 2 minus 1, which will give us what? 1. Are you with me? So let me write the rule. Let me write the expression. So we have 1 times 2. Subsequent solution, I won't be doing this again. Are you with me? So the power 2, the coefficient 1, then I write what? X bar, say what now? 2 minus what? Minus 1. For this first part, then minus. Where is the coefficient here? 1. Where is the power? Minus 1. So I'm having 1 times what? Minus 1. I'll write this x bar, x, then minus 1, minus 1. I'm using this general rule to solve what now? This sum rule. Are you with me? So what do I have here? 1 times 2, we have 2. X is power what? 2 minus 1 is what? Is 1. So I don't need anything here. So I have minus times minus. I have plus. Be careful. They have x raised to power minus 1 will give us minus 2. So this one will still come down. Now we have been 2x plus 1 over x raised to power 2. The correct answer to this question is A. So we've done ways of denoting derivatives. What is the meaning of derivative? We are asked to find the result of the differentiation of a function. That's what we call derivative. Is that clear? Then we've done general rule of what? Of differentiation. We've done the what now? Derivative of the what? Of the sum, which we call the sum. Let's go to the derivative of the what now? Of a constant. So if a is a constant, derivative of a constant is 0. Okay? Derivative of a constant is 0. So let's go. If k is a constant, if k is a constant, the x of a constant is what now? Is 0. Meaning dx, find the derivative of a constant, it is 0. Suppose, for example, we have y equals to 5. What is dy dx? Because this is a constant, our answer equals to what now? 0. If y equals to what now? Minus 10. Y equals to minus 10. Another example. Y equals to what? Minus 10. What is dy dx? Minus 10 is a constant, our answer equals to what now? 0. Remember, you have to find derivative of a constant. Our answer will be equals to what now? 0. So let's go for my examples here. Look at this. Suppose I'm given m equals to 2n raised to power 5 minus 4n squared plus 94. Then evaluate the n over what now? The n. What do you mean? Find the derivative. So what will be our answer? We use the sum rule. Here I told you I won't be doing what I did here. I'll just tell us the answer. So our dn, I think you by now you need to know what I'm doing. The n will be, the n by the n will now be 5 times 2, which is 10. The n is power 5 minus 1, which is 4. Okay, minus 2 times 4, that is 8. N is power 2 minus 1, that is 1. I need to write that one down. Then plus, as well as the constant. The percentage of the constant we have what now is 0. So our final answer will be 10n raised to power 4 minus what now? Minus 8n. Minus 8n. Okay? So let's go to the next one. I'll show you some more question. So let's take this. 4x cubed minus 8x squared plus 3x plus 15. Y equals to what now? 4x cubed minus 8x squared plus 3x minus 18 plus 3x minus 18. So we have to find the y dx of this question. So let's go. So what do I have here? Our y dx will be equal to general rule 3 times 4, that is 12. So I have 12x. 3 minus 1, I have 2. Okay. The minus 2 times 8, 16. Then x back 2 minus 1, let me try that. Then plus half. 1 times 3, I have 3. Are you with me? You know, we have 1 here. So 1 minus 1 is what now? Is 0. Then what is x to power 0? That will give us what now? 1. Let me use this one separately so you understand what I'm saying. Suppose I have y equals to what now? 3x. And I want to use what now? General rule. So the y dx will be equals to 1 is here. 1 times 3. So we have 1 times 3. I'll write s bar. Then I have 1 minus 1 minus 1. This will now be 1 times 3. We have 3. S raised to power what now? 0. What is s raised to power 0? 1. So this one will be also 3. So it means the derivative of 3s is 3. Then plus minus 18 is a constant. The derivative of the constant will give us what now? Is 0. So our final answer here will be 12s squared minus 16x plus what? Plus 3. So we are done with what now? The derivative of a constant. So let's go to the next, which is the derivative of a product. Okay, if you can watch this video, okay, just be calm, watch the videos. You won't have any problem as far as differentiation is concerned. When you do everything, both differentiation and what now? Integration. But here, we are dealing with what now? Differentiation. Just be calm, be relaxed, calm like this, okay? And watch the video over and over. I told you from the beginning, you cannot escape question under calculus in JAM. Either in JAM or in what? And why? So you do this video. Okay, please share this video, subscribe to our channel to have more videos, and click the what now? That bell icon. Click it, the red bell icon, click it so that you can be able to subscribe and you get notified anytime we are releasing amazing videos like this. We have more videos to release, okay? So we'll continue. The next one is what now? Derivative of the product. Derivative of the product. So let's go for that one. For the product. So after that, I'll now summarize everything. I'll give you summary of all the laws. So for the product, one product law, product rule, or product law. So it says if y equals to what now? uv, that is u times v. Okay? Where u and v are functions of x, then class, I think you know what we are doing here. We are finding derivatives. So dy dx will be equals to, pay close attention here, u times the v dx plus v times the u dx. Okay, so this is the rule under what now? Under product. This is the rule under product. We have u, this one, times derivative of this one, then plus v times derivative of this one now, of this u. For example, what we are given this, let me do it here. Is this one okay? This side is okay? So let me do it here. So example 1. So we have y is equals to 2s squared plus 4 bracket s plus what now? Plus 2. Now class. It is good to know the formula. Very, very good. But you must know which formula to be used to solve a particular question. We have plenty of formulas under what? Differentiation. The most important thing, the key factor here is to know which particular formula that we can use to solve a particular question. That's the reason why I'm giving you what now? All this what? Explanation first. Whenever I see a question that involves something times something, it is product. Are you with me? What I see something times something. That's why I wrote if y is what now? U times v. U times v. This is product rule. So here, good. This is product. This one times this one. So I will represent this one by what? By u. This one is u. And this one is what now? Is v. Are you with me? So for the solution, I'll give this shortcut. Okay? So for the solution, we say our u is equal to what now? 2s squared plus 4. Our v equals what now? S plus 2. Now say in this case now, u is a function of x. In this case, v is a function of x. It means v depends on x. Here, u depends on x. So in this case, we are looking for what now? The u, the x. This is because what? 2 times 2, we have 4. Then we have our x bar. Then 2 minus 1, 1. This is a constant, 0. Here you go. I'm looking for what now? The v, the x. Now, what are you going to do here? 1 times 1, 1. Then write our x back. So you know, 1 minus 1 is what now? Is 0. So here we're having what now? 1 x is power what now? 0. What x is power 0? 1. This one is going to what? It's 1. So the derivative of x plus 2. This is a constant. What is the derivative of a constant? Is 0. So you go off. This derivative of this place is 1. So what's the formula? Our dy dx equals to what? U dv dx plus b du what? dx. So this will keep our u constant. Where's our u? 2x squared plus 4. Okay? Then times what are dv dx? That is what? 1. Then plus what are b? Our b is x plus 2 times what are du dx? That is what now? 4x. This will now give us what? 1 times anything is what? Is that thing. So I have 2x squared plus 4, then plus, open this bracket, 4x times 4x, now 4x squared plus 4x times 2, we have what? 8x. So we now add everything, 2x squared plus 4x squared, that will give us 6x squared plus 8x plus 4. So the answer to this question is 6x squared plus 8x plus, I'm just giving us small examples before we take what now? Before we take bigger example from what? Look at this. Let us put this one in bracket so I will not make mistake. So one and so should be here. One and so should be. Is it clear? This is addition between them. So it's very, in fact, it's okay like this. This is in bracket, something in bracket. So I will move on and make what? Make mistake. I'm just giving you small examples before we go to what? Jam questions and by question. Are you with me? So let's go. Let's go. Look at what we have here. Look at what we have here. This is 2x squared plus 4 times 1. Don't make mistake here. I'm having 1 times anything is what now? Is that is okay like this. It's okay like this. That's just the result. So I'm putting what now? Bracket here so I don't want make mistake. And this one too. This one here. Be careful. I'm using this 4 to multiply everything in this bracket. 4x times x, 4x squared. 4x times 2, 8x. Is it clear? Is it clear? So don't make mistake, please. Right, because this place you can easily make mistakes. So I'm laying more emphasis. See where I'm shouting on this one now. So I don't want to make mistakes. Because I'm very sure after you are done watching this video, your jam mathematics, if you don't score 98, something is wrong somewhere. If you don't score 98, something is wrong somewhere. Jam mathematics, then your follow math, all that class will clear everything. Just pay attention to this video. All the video that you need in calculus is this one. Once you watch this video, nothing again. Because I'm going to take my time to demystify calculus. I'm going to give you shortcuts. So when you see OBJ, use this form. When you see theory, use this way. Are you with me? Let us continue. Let us continue. So what's the next one? Composite function. Composite function. This one is very interesting. Very, very interesting. Composite function. Look at the rule. I just have one question. You've asked me some more questions just to do this or to today. So, composite function. In JAM, they said, what is another name for function of function? We call it chain rule of differentiation. You can call it composite function or function of function. Okay, what is the rule? We call it what? Another name is what? Chain rule of what? Differentiation. So we have chain rule. For chain rule, this one is very, very interesting. Very, very interesting. So the rule says, yeah, because we have composite functions. So if y is a function of u and u is a function of x, it means you depend on your mommy for food. Your mommy depends on your dad for food. We're having two functions here. You see it? So whenever you have multiple function, it is function of what? For I depend on my mom for food. My mom depends on my dad for food. Function of function. You see two functions here. You can see multiple functions. So what is the rule? Our dy dx, or let me just put it out first, so you understand the concept very well. If I give you the formula. So what's the first one? y depends on u. So we have y is a function of what? Of u for this one. Second one, u depends on x. U is a function of what? Of x. So here, we're looking for what now? dy du. Am I correct? Because y depends on u. In this case, u depends on what? On x. Here, we're looking for what? Du dx. We have to find the y dx. What are we going to do? We just multiply these two functions or these two what now? Derivatives. So we now be having the y over the u times the u over the x. If you look at this thing clearly or closely, you see that the u will cancel the u. We now be left with what now? The y dx. So other function of functions, what we are trying to do is just to what now? To multiply, okay, two or multiple what? Derivatives based on what we are given. Yeah, we are just given two functions. We are given three functions. We will find the derivative of the three functions and now multiply two together. How do you know that something is shareable or function of function? You see it in this form. See it in this form. Are you with me? See it in this form. If you have something like this, evaluate d dx of 3x squared plus 4 raised to power what now? 3. You see it? What we have inside here is a function. It's now carrying something like what now? Something like what do you call it now? The orange bar. Yes, orange bar. Orange bar of what? Of a cow. So whenever you see a question that has orange bar, a function have multiple functions. See, look at this one. 3x squared plus 4. A function on its own. But if you ask me like this, 3x squared raised to power 3. This is not function of function because this one means 3x squared times 3x squared times 3x squared. Are you with me now? This one is I have 3x squared plus 4 inside the bracket, and now another bracket outside that carries what now? That carries 3. This is what we call here. I'm going to shock you here. Okay, I'm going to shock you. I'll give you a shortcut. So in Jam, use the shortcut. Pen. Get your answer. Without wasting what now? Time. But let's solve it theoretically for those that are writing what now? Why? Or other exams. So here, we can solve this. So it means y, the y dx. The dx of this function. So it means our y is equals to 3x squared plus 4 raised to power 3. That's the meaning of this. The dx. Did I told you that ways of writing what now? Or denoting derivatives. You can have it like this too. The dx of something. So here, now say let u to be equal to what's inside the bracket. Okay? Let to be equal to this. So if this one is u, it means y will be equal to what now? U raised to power 3. Is it clear? But everything here is u. Everything here. We've denoted it as what? As u. So it means our what? Our y, therefore, y will be equal to what now? U raised to power what now? 3. So what do we have here? U is a function of what? Of x. Our du dx here will be equal to what now? 6x. You know that? Then our dy du here will be equal to what now? 3u raised to power 2. If you are applying the general rule of what? Of differentiation. So let's go. What are the y dx? Because I have to find the y dx. So our dy dx, using the rule of what now? Chain rule, we have du, the y over du times du over the x. So what do we have here? What are the y du? That is 3u squared times what are the u dx? That is 6 what now? 6x. So now multiply 3 times 6x. That goes what now? 18x. Then u raised to power what now? 2. But what is our u? Our u is 3x squared plus 4. This will now become 18x open bracket 3x squared plus 4. Everything raised to power what now? Raised to power 2. That's the answer to that what? Question. But let me just show you, like I said, let me give you the shortcut. If you are writing jam, don't use this formula, use the shortcut. But for YA, theory YA, it's OBJ YA, use the shortcut. But for jam, use it because jam is what now? OBJ. Are you with me now? So use the what? The short. What is the shortcut? Feel the short. Very interesting. Let me give you the shortcut. Very, very interesting. So let's go for shortcut of chain rule. Shortcut of chain rule. Keep this question. Sorry, keep this formula handy. Keep it handy. So if y equals to ax plus b raised to power n, you see it? Similar to what we have here. Something in the bracket raised to power. So n is that 3. Then ax squared plus b, ax squared plus 4 is just something like as plus what now plus b. The rule says our dy dx. I will bring this power down n times. I will differentiate what I have inside here. dff means what now? Differentiate. I will differentiate ax plus b times. I will write this thing back. I will write ax plus b. I will write it back. I will now subtract 1 from the what now? From the power. From the power. This is the formula. Or the way I apply it, if I do somehow to you, let me apply it. If I do somehow to you. So ax plus b raised to power n minus 1. So let me apply the formula there from this question. So that thing works. It works. So let's go. So what's the question? Y equals to 3x squared plus 4 raised to power 3. So let me apply the shortcut. What's the y dx? What's the process? I'll bring the power down. So I'll bring 3 down. 3 times. I will differentiate what I have inside here. So differentiate 3x squared plus 4. That will give us what? 6x. I mean now, when I differentiate 3x squared plus 4, I have 6x, isn't it? I will write this thing back. So what am I writing back? I'm writing what now? 3x squared plus 4 back. I will now subtract 1 from this power. That will be 3 minus 1. So if you join everything together, okay, if I simplify it further, we'll be having 3 times 6x, 18x, open bracket, 3x squared plus 4 raised to power 2. Class, I encourage you to be using shortcut in JAMB. They will pack questions under chain rule. That's what they do. They will pack questions under one because they want you to waste time applying this normal formula. But today, we've learned one thing, shortcut under function of function or composite function, or we call chain rule of differentiation. That's the shortcut. Let us solve more questions. Let's solve more questions. Okay. Let's see. Okay, this one involves trigonometric functions. So, okay, fine. Let me just do this one for you. So I won't go far. 1994, question number 39. 1994, question 39. As another version that can use to solve third question under differentiation. Okay? After you've gotten your derivative, you now say you should put what? A value. Something like this. You can check it out. 1994, 39. 1994, question 39. So the one says if y equals to 3t cubed plus 2 squared minus 7t plus 3. We now have to find, find the y dt at t equals to what now? Minus 1. T equals to what now? Minus 1. You can ask something like this too. So we have to be very careful. Meaning, after you've gotten your what now? Derivative. You now put anywhere you see t, put minus 1. It's as simple as that. So what's the first one here? So we solve. Our y equals to what now? Sorry. Let's take our y dt straight up. What are y dt? 3 times 3 have what now? 27. Sorry, 3 times 3 is 9. 3 times 3 is 9. So 3 times 3, that is 9. Then t raised to power what now? 2. 3 minus 1. Then plus 2 times 2 is what now? Is 4. 40. And what now? Minus 7. Constant. So I think by now you should know how to differentiate. 3 times 3, 9. 3 minus 1, 2. Then plus 2 times 2, 4. 2 minus 1, 1. 1 times minus 7, 1 minus 1 is 0. 3 raised to the power 0 is 1. Constant is 0. So we now say our t is minus 1. So anywhere we see t, we put minus 1. This one become 9 bracket what? Minus 1 all squared plus 4 bracket minus 1 minus what? Minus 7. So what do we have here? Minus 1 times minus 1, that is what now? 1. 1 times 9, we have what? 9. 4 times minus 1 minus 4, we have what now? Minus what? Minus 7. Okay? 9 minus 4 is 5. 5 minus 7 is what? Minus 2. I'll just give us the option. We have minus 1, 1, minus 2, 2. A is minus 1. B is 1. C is minus 2. D is what? Is 2. So the correct answer is what? Is minus 2. Okay? So you can give us a question like this. Oh, this one is sum. I think you know. It is sum, but sum in another version. After you put in the derivative, now put in what now? The value that you are giving. So what's the next one? What is the agenda? That's what now? The derivative of the quotient. Class. We're moving to what is very interesting. Trigonometric function. Trigonometric function. So quotient, we have it like this. Quotient. Please don't forget the word now. Short word under function of function. So for the quotient, we have this for the quotient. Pay close attention. So whenever you see a question says y equals to u over b quotient, something over something, quotient. Okay? Then u and b are functions of x. U and b are functions of x. Function of x. Then our dy dx, this one is equals to v du dx minus u dv dx all over b squared for quotient rule. For quotient rule. This is quotient. Okay, let's see the question now. Shortly, let's see the question. But not all questions that we should work now. Quotient, be careful. Be very careful. You just write out. Can you just manipulate it first? If you can manipulate it, then there's no point using what now? Quotient rule. I'm looking for a question. Okay, that we can apply what we call quotient rule. Okay, fine. 2008, jam question. 2008. Okay, they will test you because this one, when you can solve this one, it's look at the formula. You first get your u dx, then your b dx, then your b square. So you first try. Can you manipulate? See this question. If you can manipulate it, then no voila. Okay? So look at this. 2008. God says, find the derivative of s raised to the power 7 minus s raised to the power 5 all over s raised to the power what now? 4. Let's just put the option here. A, s bracket what now? S squared minus 1. B, 3s bracket s squared minus 1. C, 3s squared minus 1. D, 7s raised to the power 5 minus 5 raised to the power what now? 4. Class, now look up. Look at this one. You might be tempted to go and use word now, the derivative of the word will be quoted. Be very careful. Like I told you, the first thing is what now? So look at this now. So you might be tempted, okay, to go and use what now? The derivative of the word quotient because you saw u over b. Be careful. I told you the first thing, can you manipulate this one? Can I separate the division? It's very possible now. But this one here is same as saying what now? S over 7 all over s power 4 minus s power 5 all over what now? S power 4. You see it now? So it means this one here is same as saying what now? S power 3 minus what? Minus x. You see it? S power 3 minus x. So this one will give us what now? The derivative of the sum. Although when you use this one here, you get the answer, but it will take time. What are we going to do here? We just have, this our y is s cubed minus what? Minus what? Minus x. So what's the next thing here? So we have our dy, the x will just be equals to, 3s squared minus 1. That's simple as that. Of the what now? C. Okay? 3 times 1, 3. Minus 3 minus 1, 2. Then this one is 1 times minus 1 minus 1. 1 minus 1 is 0. I think by now you should be able to know what the dimension is or power. So this is what we call the derivative of the quotient. So what's the next one? We have what now? The derivative of the trigonometric function. So I'll give a table. I'll give you a table. It's that table that I'm going to be using to solve what now? Questions. I'll give you a table. I'll give you a table. Okay? So let's go. For the table, we have this. Pay close attention for the table. The table we have this. Trigonometric function. So if y, that is, y is a function of x, okay, what will be the y dx? The y dx is just what now? F prime, I think you know that. F prime of what? Of x. So, whenever you have to find the derivative of sine x, you know, we have 3 trigonometric ratios, okay? About trigonometric functions. Yes, we have sine, we have cosine, and have what now? We have tangent. Okay? Inverse of all these 3. You have what about sine? Cosec. What about cos? Sec. What about tan? Cot. This is cotangent. Cosecant. Cotangent. Secant. Cosecant. Cotangent. So if I also differentiate sine x, if I also differentiate sine x, okay, this one is cosecant, this one is secant, this one is cotangent, okay. But when we evaluate them, equation, we have cosec, we have sec, we have cot. Are you with me now? So whenever you have to differentiate sine x, you must have cos x. You know what's funny? When you check your past questions, past question, they will pack the remaining functions there. Okay? They will pack plenty of the remaining functions there. Because they know that they don't like it. They don't. So that's why I'm doing this. So don't make this attention. Okay? Constant reading makes a wise person become wiser. Okay? If you are seeing the first time, you can do somehow. When you pause the video, look at what I said or what I wrote. Then try and memorize. I'm not using any book. This series is any book. I'm not using any book to teach. So it shows that you can do better. You can do better. Okay? That's why we are here. We want to simplify teaching. That's why we are here. Okay? So if you have any challenge, I'm going to drop our numbers I can call. Any challenge, you call our numbers. Okay? And we have what? We have our paid class that you can join. For those who are using JAM, right? Just pay 10 small token. Okay, you'll be shocked with the amount because fee that you pay. Join our WhatsApp and Telegram group for more videos. Confirm, comprehensive, analyzed videos on maths, physics, chemistry. Okay, why should I pay chemistry? Will tell you. Why should I pay physics? Will tell you. Why should I don't like maths? Will tell you. Join our paid class, you will enjoy more. But let's go back to our video. So yeah, differentiate cos x. You must add what? Minus sine x. Differentiate tan x. You have sec square x. Okay? So I've done the 3. 1, 2, 3. Let's now go to their what now? To their reciprocal. You have to differentiate sec x. You have sec x tan x. If I have to differentiate cosec x, we have minus cosec x cot x. If I have to differentiate cot x, you have minus cosec square x. Let me now give you Jara. If that now involves a constant or maybe it has a number in front, maybe something like sine ax. Our answer will be what now? A cos ax. I'll tell you the reason cos ax. Our answer will be what now? Minus a sine AS. Shortcut. If I have tan AS, that's how we work now. A sec square AS. It means differentiate what I have here. If I differentiate AS, I have A. If I just sign, I have cos. Now write AS back. I will give you questions from JAM, okay, for this. So let us stop here. This is what now? The formulas, derivative of what now? Trigonometric functions. Let's have a question from JAM. You notice I will not be wasting any time. Question from JAM. So I see that JAM, plenty questions there. Plenty questions there in JAM. Under what now? Derivative of, can you imagine 2001, 2011. Look at the question. Find derivative. Find the derivative of sin theta over cos theta. The first option A, sec square theta. B, cosec theta, sec theta. C, cosec square theta. D, tan theta, cosec theta. Now class, smile. Okay, let's continue to smile. I want to see you scatter your jam, math jam. You scatter it. I'm telling you, 98 minimum. 98 minimum. If you don't score 98, it means to gain you. Because 98 is very easy to mathematics. See what is happening here. Oh, I have U over V. I can use quotient rule. Sure, you know. Whenever you have U over V, is quotient rule. But be careful. Jam want to test you that you understand the concept. Are you with me now? So this will now take you to what we call basic trigonometric identities under trigonometry. Maths are interwoven. Topics in maths are interwoven. This one here, that's why it's no, you don't need to do anything. Don't say you is this. No. See what is happening. See what is happening. See what is happening. Anytime in this world, that we call basic identity. Basic identities. Although I think we should do personal work now. Trigonometry. Anytime I have tan theta, tan of something, okay, let me say tan x, tan of something, it must give me sine of that thing all over cos of that thing. You see it? Do you see what I'm saying? It means what they want us to do there is find what now? Tan theta. What is tan x? Sec square x. What is tan theta? Sec square theta. You don't need to do anything. Are you with me? Because I know that tan something must give me what now? Sine of something by what now? So it means what they want to test here is your basic identity combined with what now? The derivative of what? Trigonometric function. Is it clear? I know. Note. You don't want it again. Okay? Note that what now? Sin theta over cos theta equals to what now? Tan theta. I'm going to confirm that. Okay? So it means here, let me just confirm. You know that sin 30, look at this. Sin 30 is 1 over 2. Cos 30 is root 3 over 2. What's that tan 30? And then this is what now? 1 over what now? Root 3. 1 over 3. Let's confirm if this thing is true or not. Let's confirm. So let's go. So it means sin 30 over cos 30. What will it give us? Will it give us 1 over root 3? So let us go. What's sin 30? 1 over 2 divided by what's cos 30? Root 3 over what now? Over 2. Change this sign to what now? Multiplication. I'm having what now? 1 over 2 times 2 over what now? Root what? Root 3. This is not how this. I have what now? 1 over what now? So it is confirmed that sine of something over cos of that thing will give us tan of that thing. So here, I'll just go. So sin theta over cos theta equals what now? Tan theta. So let's find dx, the derivative of what now? Tan theta. And what now will give us? Sec square theta. So is x, so x, if it's theta, it will be what now? Sec square what now? So answer is what now? Is A. Without wasting our time. So let's go. Let's solve more questions. Let's solve more questions. under uh, okay, okay, okay. If y is s sin x, find the y dx. If this is another jam question, if y equals to s sin x, find the y dx. S sin x, x sin x. I'm going to be using this, so let me mark it up. S sin x, x sin x. So we have our y to be equals to x sin x. Find the y dx. What does it mean? Product rule. Product rule. So it means our u is what? Is b. Our u is x. Our b is what now? Is sin x. So our u equals to what now? X. Our b is what now? Sin x. So here, the u dx is 1. The b dx, yeah, when it's sin x, we have cos x. So this will be what now? Cos what? Cos x. So what are the y dx under product rule? That will be u dv dx plus b du what? Dx. So this will now because we are, let's go. Our s is what? Our u is what? Is x times what are the b dx? Cos x. Then plus what are b? Sin x times what are the u dx? That is y. So our answer equals to what now? S cos x plus what? Plus sin x. This is the question. This is the question. Okay. So under what now? Under what do you call it? Derivative of what now? Derivative function combined with what now? With product rule. So let's have more question. Let's have more question. Okay. Look at this question. 2006. 2006. 2006. We have differentiate. 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 Cos theta minus sin theta raised to power what now? 2. I'm going to with respect to theta. With respect to theta. What's the class? What's the ratio? Yeah. I'll use share rule. Share rule combined with what now? Derivative of what now? Trigonometric function. Is that what? So what will I do? I want to apply share rule. So I'm having answer will be bring these two down. Shortcut. I'll bring the two down. So I'm having two. Let me write the options out first. Let me write the options out. Fine. So let me write the options out. So we have A minus 2 sin theta, B minus 2 cos theta, C 1 minus 2 cos 2 theta, D 1 minus 2 sin 2 theta. Alright, so let's go. If I apply the share rule, shortcut in share rule, we have this. Shortcut in share rule, we have this. So let's are looking for dy theta. Dy theta will be equals to, I'll bring 2 down, 2 times, I will differentiate what I have inside here. So I'm having cos theta minus sin theta. So differentiate cos theta minus sin theta will be product rule again, 1 by 1. What is the derivative of cos theta? Minus sin theta. Then minus is here, minus is here. What is the derivative of sin theta? That will be cos what? Cos theta. Then what? Close the bracket, close the bracket. I will now write this thing back. I'll now subtract 1 from here. So I'm writing what again? I'm writing cos theta minus sin theta back. Okay? And now I have 2 minus 1 here. I'm applying shortcut, another what now? Share rule. Shortcut. This will now be equal to what now? 2 times minus sin theta minus cos theta. Another bracket what now? Cos theta minus sin what now? Theta. Is it okay here? Is it okay here? Can we continue here? Is it okay? Alright, so let's go. Let's go, class. What's the next thing? Open the bracket. Open the bracket. So I'm having 2 times minus sin theta times cos theta. That will give us what? Minus sin theta cos theta. Then minus sin theta times minus sin theta. That will be what now? Plus sin square theta. Okay? Then minus cos theta times plus cos theta. That will give us what now? Minus cos square theta. Okay? Then minus cos theta times minus sin theta. That will be plus what now? Sin theta cos what? Cos theta. Are you with me? So pay close attention to this place. Having this, having this. So what is happening? Plus sin theta cos theta minus sin theta cos theta plus sin theta cos theta will cancel out. So let's say I'm having 2x minus 2x. So this one will what? Will cancel out. So I'm having sin square theta minus cos square theta. Look up. That will be 2 bracket sin square theta minus cos square what now? Theta. But it's not the option. You check our option. This one. Well, this is the answer. This is the answer, but it's not in the what now? It's not in. What are we going to do? Either we change this one to what now? To cos, or we change this one to what now? To sin. Now collect that sin square theta plus cos square theta give us what now? 1. So let me try and change this one to what now? To cos square theta. So I'm having for every sin square theta, I have 1 minus cos square theta. This one will now be what now? 1 minus. Look at this, look at this. This is a fact under trigonometry. Basic identity. For every sin square something plus cos square that thing will give us what now? 1. So let us make this one solve a formula. It means this one here, come to this space, it's not be 1. So with this here, we now have 2 open bracket. Instead of writing sin square theta, it should now be 1 minus what now? Cos square theta. Then minus cos square theta. Again, so open the bracket, I'm having 2 brackets, 1 minus 2 cos square theta. What is 1 minus 2 cos square? That is what now? Cos 2 theta. Is it there? Yes. 2. Look at this. Cos theta. How do you get that? This is minus is not there. We have 2 cos theta. Look at this. Basic identity. I'm having 1. Let me write the basic identity out. The first one. Tan theta must give us sin theta. Is it okay like this? All over cos theta. Then the second one. Sin square theta plus cos square theta will give us what now? 1. Then third one. 1 plus tan square theta equals to sec square theta. Then the fourth one. Cos square theta plus 1 is equals to what now? Cosec square theta. Class. We are going to learn plenty things in this video. Plenty things. Alright, that one aside. Now, let us go to what we call double angle formula. Double angle formula. This one is just bringing us to what we call double angle formula. Look at this. If I have cos A plus B is equals to cos A cos B minus sin A sin B. If this angle is now double angle, meaning our B is A, we will have cos A plus A. This will be cos A, cos A. Anywhere we see B, we put A minus what? Sin A, sin what? Sin A. So this will now be equal to what? It means cos 2A. Cos 2A is equal to what now? Cos square A minus sin square what? A. But class, what is cos square A? Or what is sin square A? What is sine square A? Sine square theta is 1 minus cos square theta. It means sine square A will be 1 minus cos square A. Are you with me? So it means I'm having cos square A minus, open bracket, 1 minus cos square A. So what do I have here? Cos square A minus times 1 is what? Minus 1. Minus times minus is what now? Is plus. Cos square what? No, cos square A. So it means cos 2A is equals to 2 cos square A minus 1. Do I have it here? I have 2 cos square A minus 1. Cos square A minus 1. So here I mean 1 minus 2 cos square A. So if I reverse, okay, look at this. Look at this. You get what I'm trying to say. So it means for double angle, cos 2A in this word, this is the formula. I just put the formula, you don't need the proofs. Cos 2A is 2 cos square A minus 1. Or I have cos square A, cos 2A is this one too. I have formula for cos 2A. See, this one is under trigonometry. Are you with me? But calculus is telling us you must know trigonometry. You must. So cos 2A is cos square A minus sine square A. Cos 2A is 2 cos square A minus 1. Look at this class. I gave you this formula before. I said under algebra, m minus n is same as saying minus bracket m minus n. It's a fact. You see it? It's a fact under algebra. So if I say, okay, let me assume that my m is 10 and my n is what now? Is 4. Let us show that this thing is correct. Let's go. What is 10 minus 4? That is 6. For this value, will it give us minus bracket? What are our n? What are m? This is n minus, sorry, minus m minus n. So what are our n? This is 4 minus, what's our n? We have 10. So what do we now have here? Minus bracket, 4 minus 10 is what now? Minus 6. Minus times minus will give us what now? Plus. So it means m minus n is the same thing as minus open bracket n minus n. That is what is happening here. You know, the correct answer is supposed to be 2 cos square A minus 1. But here I'm having 1 minus 2 cos square A. So if I introduce minus, what is it to happen? So if I introduce minus from this concept will be minus 2 open bracket, what is it to happen? Rather than be 2 cos square theta minus 1. Is it clear? From here. That's very interesting. Very interesting. What I do here, I use this concept. M minus n is the same thing as what? Minus open bracket n minus m, which I prove here. So, which imply 2 open bracket 1 minus cos square theta is the same thing as saying put minus out, give us 2 cos square theta minus 1. And what is this one? We are having what now? 2 cos, look at this, cos 2 theta. Cos 2 theta. Because here, we're supposed to have cos 2 theta. So this one will have gone minus 2 cos 2 theta. And the correct answer to that question is, this thing is long. Just pause the video and see the way I explain the word now. Because, okay, so I'm moving from calculus into trigonometry. See the rule. See you have done it. Okay, so double angle formula is a fact. Sine square theta plus cos square theta plus what now? Plus 1. So what is sine square theta? So we'll come here, I have this, then open the brackets. Just pause the video and I don't understand, then give us what now? A call. Okay, this is what we call derivative of the what now? Trigonometric function. Let me do the derivative of the what now? Of the linear function and the unit function. So I've not ended this word. This will now solve more questions under JAM. So that's what we're going to do. Please know this one, please. Write it down because we're going to use this one under what now? Under trigonometry again. Write this one down. Double angle formula. Cos 2a is 2 cos square a minus 1, or cos square a minus what now? Sine square a. Alright, so let's go. Let's go. So here, what are we having here? Next one. Oh, I've cleaned the guide. So I think that should be the next one should be O. Right. Derivative of the what now? Derivative of the exponential function. Exponential function. This one is no wala here. Meaning if y equals to what now? E raised to power what now? Ax. Our dy dx equals to differentiate what I have here. Differentiate ax. Are you with me? So I'm having d dx of ax. Then I will multiply by what now? E raised to power what now? Ax. Example. Evaluate e raised to power tan x. Evaluate e raised to power tan x. What's the answer, class? What will I do? I will differentiate what I have here. Differentiate what I have. This is what I put here. Differentiate what I have on top. Are you with me? So I will differentiate tan x. If I differentiate tan x, I will have what now? Set square x. So answer will be this is our dy dx. Evaluate d dx of this. Sorry, d dx of this. So our dy dx will now be equal to evaluate this. I have set square x. I will write e raised to power what now? And x. You need to kill yourself. I'm just working on function, but I'm telling you the shortcut now. Okay? Working on function, I'm telling you the shortcut. So what are you going to do? If you have e raised to power as under exponential function, just mention what you have on top, multiply by the question back. So mention tan s, you have set square s. I will now multiply by what now? E raised to power tan s. I don't want this video to be too long. So let me just do the logarithmic function. Give you all the derivatives and the rest we will continue in the next video. So now derivative of what? Derivative of logarithmic function. Logarithmic function. And this if what? If y equals to log of x base e. Log of x base e is same as in what now? In e or in x, sorry. In x. Log of x base e. Log of any number to base e is the what now? Meaning of that number. So our divide dx, see what the thing is saying. It means differentiate x out was what? 1 all over. Put that x back. That's all. That's all. Whenever you see log of an expression base e, our answer is differentiate that expression all over that thing back. For example, look at this. Example. Differentiate log 3x squared base e. What's the answer, class? I will differentiate what I have on top here. That is what now? 6x all over. That is in back. 3x what now? So what happened? 3 here 1, 3 here what now? 2. 1x equals 1x here. So answer was what now? 2 all over. I'm having just ordinary what now? X negative. Is it clear? That is just the rule. Shortcut. So when the thing involves log of 3x squared base e, log of base e of an expression. Imagine that expression all over that. Let me just give us one example question. I think I saw one example question here. I think yes. Oh, I love this question. So guys, find dy dx. Good. Find dy dx. Where should I write off? Okay, let me write this off. So I'm still maintaining the rule. So find dy dx. Find dy dx if y equals to log of tan 2x base e. Now, what is the solution? Don't kill yourself. What's the solution? The y dx will be equals to what now? Don't stress yourself. What's the y dx? What's the rule? Differentiate what I have on top here, all over that in back. So differentiate tan 2x. You know I gave you tan ax. I gave you tan ax. What is it? That is what now? Ax squared ax. You see the connect. Under what now? Derivative of what now? Denominatic function. I gave you tan ax is what now? Ax squared ax. What do I do here? That will just be 2 x squared 2x all over right in back tan 2x. That's my answer. Without doing anything. Okay? Make sure you understand the concept. When you think about what logarithm, you differentiate what are given all over that thing back. So derivative of what now? Tan 2x is what now? 2x squared, 2x. Then all over tan 2x back. That is what now? That is the answer. We're seeing some more questions, okay? But this video is becoming too long. Okay, so I want to take one more and we'll pause the work now. We'll round up the video. Please subscribe to our channel. Please, for begging, subscribe. Okay, and help us to do more, okay, by assisting the channel to grow. Okay, you can just pay into our account. No amount is too small, but make sure you subscribe, comment. If you enjoyed the video, comment and share the video so those writing WAEC and JAM, they must all see this video. Before they write JAM, they should not write JAM until they watch this video. They should not write WAEC until they watch this video, because this video will simplify everything under calculus for them. If you enjoyed the video, please in the comment section below, okay, and subscribe to our YouTube channel. Just click the red subscribe button and turn on the notification bell icon. What's the reason? So anytime we release videos, amazing videos, you get to see the video. You see prompt, pam, that a video has been released by noticer, and be the first person to watch it. So the last one is what we call higher derivatives. What do I call it? Higher derivatives. Higher derivatives. So let me do it here. Higher derivatives. Higher derivatives. So let me wipe this place off. I think I should be able to wipe this place off. Wipe this place off. Higher derivatives. So look at this. Remember you have higher derivatives. Higher derivatives. What's the meaning? It means multiple function. Okay? So suppose y equals what now? F of x. What's the first derivative? Divide the x. This is the first derivative. First derivative. Then the square dy all over the x squared. This is the second derivative. Second derivative. This is what we call higher derivative. Then third one will be the cube y all over the x cubed. This is what we call the third what? Derivatives. And so on and so forth. From here to here, we call them what now? Higher. Higher what? Derivatives. There are many. Go on and go on like that. Okay? So when you have a function, so this one here will be f prime. No, f prime of x. This one here will be what now? F prime prime of x, meaning twice. So it will be f prime 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 of what now? Of x, meaning 3 times. In the exam, we can give you evaluate f prime prime of x. This one will be what now? 2 times.